In most of my previous videos, I discussed formulas for solving problems that involved linear translational motion. In this video, I wanted to discuss the formulas that you need to know for solving problems involving rotational motion. These should be based on formulas that you already know, and it's easier if you just think of them as the rotational versions of the linear motion formulas. For example, let's say that we have a wheel that rotates in the counterclockwise direction such that a point at x rotates to point P. In linear motion, this would be known as a displacement, but since this point rotates along an arc, it's known as angular displacement. The angular displacement, represented by theta, can be found by dividing the arc length by the radius of the circle. In the same way that we would calculate velocity from the change in an object's displacement, we can calculate this wheel's average angular velocity. Angular velocity, represented by the Greek letter omega, can be found by taking the change in the angular displacement and dividing it by the change in time. You've probably guessed that we can also find the average angular acceleration in a similar way. This quantity, represented by alpha, can be found by taking the change in the angular velocity and dividing that by the change in time. It's important to note that in these formulas, theta is in radians and not degrees. Also, the convention is that these quantities are positive when an object is rotating in a counterclockwise direction, but negative when an object is rotating in a clockwise direction. Just think back to the unit circle you learned about in trig. These rotational quantities can actually all be written in terms of the linear motion quantities that you first learned about in kinematics. In my previous video on centripetal motion, I explained how any point on a rotating object has an instantaneous velocity that's tangential to its circular path. If we look at this new angular displacement formula and rearrange it, we can say that the arc length is equal to the radius multiplied by theta. This might be difficult to conceptualize, but as theta gets infinitely small, the arc length that any point moves across will become a linear displacement. We can therefore say that the displacement is equal to the radius multiplied by theta. Because we know that an object's velocity is equal to the change in displacement over the change in time, we can use the previous formula to say that the velocity is equal to the radius times the change in angular displacement divided by the change in time. And because we know that the change in displacement divided by the change in time is just the angular velocity, we can say that the velocity is equal to the radius multiplied by the angular velocity. From centripetal motion, we know that any point on a rotating object has both a tangential acceleration in the same direction as the instantaneous velocity, as well as a centripetal acceleration that points towards the center of the circle. Because this tangential acceleration is equal to the change in velocity divided by the change in time, we can also say that it's equal to the radius multiplied by the change in angular velocity divided by the change in time. Since we know that the change in angular velocity divided by the change in time is just angular acceleration, we can then say that the tangential acceleration is equal to the radius multiplied by the angular acceleration. Because I mentioned that these are just the rotational versions of the linear motion quantities that you already know, we can use the same kinematics formulas that you already know, just substituting these quantities. You should be able to solve a wide variety of rotational motion problems by just choosing the correct formula to find the unknown that you're looking for. In addition, you might also encounter problems where you need to convert between the linear and rotational motion quantities. Be sure to watch my next video where I'll go through an example that involves both types of problems. If anything in this video was unclear, comment below and I'll do my best to answer your questions. If you found this video helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.